Do you want to restore your yellow plastics back to their original glory? If so, if that is you, keep on watching, because in this video we'll be restoring various yellowed plastics back to their original factory color, or at least as close as possible. So this process is going to work with various items, from old video game consoles to headlights in cars to various, pieces of plastic equipment, all the way down to refrigerators and even exercise bicycles. So the process of restoring yellowed plastics is sometimes known as retrobrighting, as it's usually retro items that have become discolored over time, and we want to brighten them up again, make them look nice and new. So retrobrighting is a hot topic of debate, but the truth is very few people have done the proper testing on this subject matter, especially observing the results over long periods of time. I did a lot of experimenting in this video and learned a lot along the way, so I'm going to share some of this experimenting with you, as well as some of my mistakes, so we can all learn from this together. But in this video we'll be discussing why this happens. So why do plastics become yellowed? What types of plastics will this work on? And how to actually restore the plastics, the process itself. Some things I've learned along the way. And how long will this process last? Will it last a week, a month, a year? How long? But the primary aim of this video is to make this process easy for you, but also keeping things cheap and also accessible. So let's get going. So why does this happen to our plastics? Why do they become yellowed over time? What is going on here? Well, the plastics that are used to make, for example, headlights in cars, they used to be glass, but now they're plastic, and you notice over time, especially in hot environments, they become yellow a lot faster. So this is the type of plastics they use in this case. There's various different plastics. There's polypropylene, which is like tote bags, tape, for example, outdoor plastic chairs. There's also styrene, like impact styrene for Tupperware, yogurt containers, plastic cutlery, salad bowls, and things like that. And another most common one as well is ultra-kilo-nitrile butadiene styrene, which you probably know as ABS, which is used in drain pipes, sewage pipes, water pipes, and things like that. So these are common plastics, and also types of plastics that can become yellowed over time. But why do they become yellowed? Because of the sun, and it's the UV radiation that comes from the sun and or heat as well. So these things turn these plastics into a yellow color, and that's because they become oxidized and develop something called conjugated unsaturation, which produces the yellow color. So the UV light comes from the sun in varying wavelengths. More on that later. So can manufacturers use different plastics, different types of plastics? Yes, of course they can. But do they? Well, not always. And why not? Well, plastics of today are more advanced in recent years. It's a lot different from 80s technology, where you see a lot of old Nintendos and Dreamcasts become yellowed over time because you've put them near the window and they can get some sun exposure. But it's also more expensive to produce a better plastic, which is more UV resistant. But typically the plastics of today, they have different chemicals and elements in there which make them a lot more UV resistant. But the aim of this video is to counteract this oxidization, this reaction that the plastic has from UV or heat exposure, using a chemical-based solution. And what is that chemical-based solution? Good old hydrogen peroxide. And if you've never heard of hydrogen peroxide, it's one of those miracle formulas that you find in hair dye, but it's also used to kill germs, it's used on skin wounds, it's used for cleaning, disinfecting, and stain removal, lots of different uses. And the good thing about hydrogen peroxide is its accessibility. You can buy it over the counter in a low strength, and we're going to be using this in this very video. So why is it that hydrogen peroxide can be used to counteract oxidization, which is the yellowing of the plastic? Well, that's because itself is an oxidizer, an oxidizing agent. Hydrogen peroxide is one of the best oxidizing agents known to man. If you're not sure what oxidization is, it's a process in which a chemical substance changes because of the addition of oxygen. Oxygen is present in the air, So something will change, combust, decompose. That is an oxidizer. So, water, H2O, good old H2O. Everyone's heard of H2O, right? It's a water, which is an atom of oxygen, O, and 2 atoms of hydrogen, H2. It's a fairly stable arrangement. Hydrogen peroxide is 2 atoms of oxygen and 2 atoms of hydrogen. So water, H2O, hydrogen peroxide, H2O2. But hydrogen peroxide in the presence of oxygen, because it's an oxidizer, UV light or any other catalysts, it will break down into a water molecule and an oxygen atom, releasing heat in the process. So why is this important? We're going to be using hydrogen peroxide, a low strength, in this video. And this is important because we know now that hydrogen peroxide decomposes into water and oxygen when the reaction with the air or UV light or both is fully complete. Therefore, if you want to reuse your hydrogen peroxide on your next plastic component, it's not going to work to its full potential, or it's not going to work at all because the reaction with the air or UV light is fully complete. So if you've ever noticed why hydrogen peroxide is in a brown bottle, well, this brown bottle protects against the UV light. It cannot penetrate the brown bottle. So let's talk about the strength of hydrogen peroxide. What strength are we going to use in this video? We're going to be using 3% because it's easily available over the counter. Anyone can get it, and it would be interesting to see if 3% could work in this procedure. Now, if you get a stronger strength, it's very hard to obtain. Perhaps you can get like a hair bleaching application where it's 6 to 12%, or a food grade one from 12 to 35% peroxide. But if you want something stronger, or even food grade, it's quite hard to find for just a common person. Typically, you need some sort of paperwork license or business, to support that you're going to be using this in a safe way. So that's why we're using 3%. But what is the volume strength on these bottles? What does it mean? Well, a 3% hydrogen peroxide is known as a V10 or a 10 volume. A 6% is 20 volume, a 9% is 30 volume, and so on. And what this scale means, a V10 or a 10 volume, it's because it will release 10 times its volume in oxygen. So, for example, 1 pint of 3% hydrogen peroxide will release 10 pints of oxygen as it decomposes, as it breaks down. So now we know what hydrogen peroxide is, how it breaks down into a water molecule and an oxygen atom, and that we can use UV as a catalyst. Let's talk about UV light. And lucky for us, we have a great source of ultraviolet light, UV light, and that is from the sun. And we're going to be using the sun as a catalyst to speed up this reaction and restore our plastics a lot faster. So let's talk about UV light. So ultraviolet light is part of the electromagnetic spectrum. That's just a fancy way of saying it's a name given to the collection of all radiation in the entire universe, from gamma rays to X-rays on one end, and then microwaves and radio waves on the other end, the difference being the wavelength. Now, visible light is a very small part of this spectrum, and that's just light that we can see, humans can see. But let's not talk about that right now. Let's talk about UV light. So has anyone ever had their teeth whitened professionally? You lie in the chair, they put this sort of stuff on your teeth, and then they shine a UV light on it. And you can kind of feel the heat a little bit. Your gums become red. This is exactly the process we're going to be doing on these plastics. What they're putting on your teeth is some sort of peroxide solution, whether it's paste or liquid, for example. It's probably paste in this application. And then when you shine the UV light on this, it releases heat. That's the byproduct of the peroxide breaking down. So you feel the heat in your mouth and on your gums when you're getting your teeth whitened. But this is how the magic happens. This is basically what we're going to be doing in this video. Now, UV light can be broken down into 3 different categories: UVA, B, and C. You've probably heard of these when shopping for sunscreen, suntan lotion, and things like that. So UVC is the shortest wavelength of UV light. It's classed as a dangerous ray. They don't really penetrate the Earth's ozone layer when coming from the sun, so it's not really something we need to be concerned about. UVB, which is like a mid wavelength, causes sunburn, skin cancer, and they're classed as burning rays. This is what you'll probably see when shopping for suntan lotion. You know, protect yourself from UVB rays. So this is the one you've probably heard of the most. And UVA, which is the longest wavelength of UV light, it reaches deep inside the tissue and skin, causing aging, and they're classed as tanning rays. And this again can be broken down further, that's UVA, into a shorter wavelength, which is used to cure polymers used in printers, and then a medium one, which is like a black light for bug attraction and sun tanning, and lastly a black light blue, which is like glow in the dark lighting that you might see in nightclubs and things for detecting forgery in banknotes. So why are all these UV wavelengths important? Well, why is this relevant to me? Well, maybe you want to simulate this indoors. You want to simulate the sun. You want to do it in a controlled environment. Maybe you live in a cold climate where you don't really see the sun that much. And you really want to know, like, can I use a UV light? Can I use a black light? Can I use something else instead of the sun? Well, looking at an article written in Medical Science, they tested various different wavelengths of UV and hydrogen peroxide and studied the bleaching effect as a result. They showed that a light source of 256 nanometers showed the highest bleaching effect over time, which is UVC. Now, it's really hard to get a UVC source because it's classed as a dangerous ray. However, followed that by UVB, 310 nanometer wavelength, and this we can get from the sun. So this is basically saying, okay, UVC is the best, but it's a dangerous ray, so it's harder to obtain. Just like getting a really strong concentration of hydrogen peroxide is harder to obtain because you need a special permit. However, if we use a lower strength of hydrogen peroxide and we can use the sun, we can still get a good reaction and hopefully restore our plastics without accessing potentially classified and dangerous pieces of equipment that we otherwise can't get. Could we use a black light instead? Maybe something for Halloween or, something from my glow-in-the-dark lighting setup? Yes, you could, but the reaction is going to be a lot poorer, a lot slower. So what I'm trying to say is if you have access to the sun and it's shining down, this would be a great catalyst for this experiment. However, if sun is quite rare in your environment, you could settle for a UV light, but I would steer away from something like a black light, for example, because the reaction time is going to be a lot slower and it may not even work so well at all. So let's move on to the experimentation process, the fun part. So the one I'm going to show first, I did 3 different experiments, but I'm going to show the last one first. I'm showing the last one first because it uses the natural sunlight, so natural UV, and then the 3% hydrogen peroxide, which you can buy readily available through most stores, like most pharmacies and supermarkets and whatnot. So the sunlight, like I mentioned, is a natural, really rich source of UV, so this is what we're going to be using. If you live in a hot climate, a hot area, then the heat will help as a catalyst, like we mentioned before as well. But it's not paramount, it's not important. But if you do put it in a hot environment, it will help accelerate the reaction, and you're probably going to see results a lot quicker than you otherwise would. However, even on the coldest day, you may notice you still get a suntan or sunburn from the sun. So don't be fooled just because it's a cold day. It doesn't necessarily mean that there's no UV rays coming from the sun. Okay, so the first thing you want to do is find the item you want to retrobright. Here I'm using an old Sega Dreamcast. It has a lot of yellowing on top. Underneath it doesn't look really too bad, but especially the top. So what I'm going to do is remove the lid from the Dreamcast and attempt to retrobright that with the hydrogen peroxide and the UV from the sun. I haven't bothered to remove any of the fastenings underneath the lid. Really as an experiment, I want to see if the peroxide is going to cause damage to certain materials. I don't really care about the Dreamcast too much, so we're going to see this at the end of the experiment as well. The first thing we want to do is clean the item with perhaps alcohol or something like that. We don't want any stickers on here or any dirt, and because when this starts bleaching, we're going to get inconsistencies. When the dirt rubs away, you're going to see a yellow patch where the UV and peroxide couldn't penetrate. So it's very important we clean this. Some plastic reacts with alcohol, so do a little patch test first before you clean the whole thing. So the first thing I did was grab a container that's somewhat transparent. This is because the sun can hit this at every single angle. If you put something in the shadow or the sun cannot directly get to this part, then it's going to react very differently. You're not going to get an even spread. So it's very important that the sun can reach every part of the item. If this is not the case somehow, then you may want to rotate it every hour or so, just so everything gets an even spread. I used a container just slightly bigger than the item because otherwise you're going to be using a lot more hydrogen peroxide to submerge the item. So it's really beneficial having a container just slightly big enough, just from a money saving aspect. And the last thing I'm going to mention, you must fully submerge your object in the hydrogen peroxide solution. If you don't, you're going to get uneven staining and it could potentially damage your item. I'll show you an item now. I used a Nintendo that actually came up out of this solution. It wasn't fully submerged. It came unstuck, a few hours into the experiment, and I didn't check it until the next day. So it has this weird kind of bleaching mark on the top that I can't seem to get rid of. So it's very important you fully submerge your items. You may want to weigh them down with some weights and tie it to the underside. You don't want the weights to cast shadows, so perhaps put them underneath the item. But yes, it's very important that everything is fully submerged through this whole process. So now let's take a look at the experiment with the Dreamcast in 3% hydrogen peroxide. What I'm showing you now is after just 1 hour in the sun. So 1 hour in that small kind of transparent container there, just soaking up the sun. This is what it looks like. You can see it hasn't really changed too much. So we're going to put it back for a little longer and see what happens. Here you can see the reaction as the hydrogen peroxide is broken down. You can see all these bubbles here, look. And this is exactly why we can't reuse hydrogen peroxide. It's giving off some heat in the process, but because it's not contained indoors, I'm not really worried about anything overheating or anything like that. So this is 4 hours later now. It's come a long way. You can see we're almost up against our kind of control here. It's still slightly yellow tinged. But after only 4 hours in the sun with just a 3% hydrogen peroxide, it looks really good and a damn sight better than it did before. So let's put it in for a little bit longer now. But before we do that, we're going to have a look at the underside and see if anything's reacted with the solution. You can see here some of the screws here have actually reacted with it. You can see they're slightly rusted, and it's really the components that aren't stainless, like the stainless steel springs look good. The kind of grey foam there looks pretty good. All the plastic looks good. But you can just see a couple screws and washers have reacted here with the solution. So when you soak your components, maybe it's something to consider. If everything's not stainless and protected, you may want to remove them. But this is just part of the experiment process. I'm trying it here so you don't have to ruin your thing. But you can see here some things have reacted, but the stainless things generally look perfectly fine. So it is definitely something important to note when doing your own things at home. So now this is 6 hours later. It looks almost fully restored. It looks really great, to be honest. There might be like a yellow tinge where there could be a shadow casted or the sun can't quite get to it. You can kind of see that bottom right corner looks slightly yellowed. But again, there's no problem just putting it in the solution for another couple of hours. It's perfectly fine. But yeah, this is after 6 hours now. It looks honestly really great, to be honest. So this is 7 hours later now. I think it honestly looks great. We could even refresh the hydrogen peroxide solution. Maybe it's fully broken down now and we need some more. But to be honest, I think it looks great, and it's a perfect example of just 3% hydrogen peroxide in the natural sunlight. It goes to show you don't necessarily need a shorter wavelength of UV like a UVA or anything like that. We can use the sun and it works perfectly well. If you look at the underside here, it looks actually slightly more yellow than the top now, and before we did this process, the bottom looked great, but now it looks actually darker, so I might consider actually doing the bottom now. but you can see in comparison from before, it honestly looks amazing. And this can work on pretty much anything out there. It doesn't have to be a video game console. It could be anything, pretty much plastic, to be honest. So now we've had a bit of a success with the Dreamcast. Here's an example of a different experiment I did where I tried to make something self-contained inside the house with just things I had laying around. I found this stainless steel cooler here. I thought it was pretty good because I could put a UV light in the top here. The UV light doesn't penetrate through the side walls. So you can see here, none of the UV is escaping. So I thought it would be a really good kind of box I can use all year round in the winter and anything like that. I tried with a Nintendo NES in here, and I had a UV light as well, slightly longer wavelength of UV than the sun. And to be honest, after around 10 or 15 hours, little had been done. I think the UV source just wasn't strong enough. I do recommend a bigger UV panel that you can get from Amazon. I'll link that below so you can try that out. It works a lot better than something like a small black light. But I tried to keep all the UV rays contained. I was using things like windscreen covers for cars, some aluminium foil, and that would kind of make sure all the UV was contained in the box. But again, the reaction was just too slow. And not only that, I couldn't get even coverage. Actually, the walls of the cooler were designed so the UV couldn't escape, but it also meant I couldn't get clear coverage on the item. So it came out a little spotty, and the reaction was honestly just too slow. I'm not saying it's not possible to set up a solution in the house. You're just going to have to put a lot more work and effort into developing something the first time, and then you can reuse it in the future. But to be honest, using the sun outside with just some 3% hydrogen peroxide, as you can see before, was so much easier and a lot less effort. So this is the second experiment I tried, and the last experiment I'm going to show you in the video. So I took the Nintendo out of the cooler. I couldn't really get the cooler to work well without getting a bigger container, even coverage, so a better UV light, and just putting a lot more time and effort into it than I really wanted to. Right now I'm living in Las Vegas where we have some great sunlight, and even if I wasn't, to be honest, I think there's plenty of sun to actually get a good reaction without that. It's just going to take a little longer, but for the time and effort, you can just leave something outside and forget about it. It's a lot easier than setting up like an in-home solution. So this is where I took the Nintendo out of the cooler. I put it in a clear container. So the bigger the item, the more H2O2 you're going to need, which is obviously going to be more money because it's not a product you can realistically reuse. So here I am covering the Nintendo now in the H2O2, and what I did, I left this outside just way too long and I wasn't really watching it too much. And this is where I noticed that if you cast a shadow on the item, sometimes it's really hard to correct this later. It's a lot more important to get even coverage. Slowly rotate your item every hour or two just to make sure everything gets coverage. But in this experiment, the solution just wasn't deep enough, and the weights I attached actually detached during the process, so it wasn't fully submerged, and then I got some staining on the top. There's no doubt I can fix this staining. It's obviously salvageable, but it is something to note. You just want to put in a lot of effort when putting your items in, making sure they're fully submerged so you get great even coverage. So you just need to put the effort in, and once everything is accessible by your UV source and it's submerged, you're going to have a great product at the end of it. So this was my second experiment, and I learned a lot about this process along the way. But I think everything I showed you in the start of the video with regards to how this process works, the UV source, the hydrogen peroxide, coupled with just shoving it in the sun with a 3% solution, works absolutely great. If you use a shorter wavelength of UV or you use a higher strength of hydrogen peroxide, you're going to get a faster reaction, but you're not going to get a better reaction. So why not just get something cheaper and just wait a couple of extra hours? It's going to work just the same, and the reaction's going to hold just as long. So I'm going to close out with two more things. Number one, what if your item is just way too big, you can't detach it from certain electronics, and this method just isn't good for you? Well, you can actually get a hydrogen peroxide kind of paste, like a foam sort of thing, and this is what they use when they brighten your teeth. So rather than a liquid, it's more like a mousse, like a foam. So you can put perfectly use that. It's no problem. You can put that on your items and spread it out. Sometimes you get a weird coverage with that. You might get some streaking. But to be honest, you have to weigh out the outcome. Is it better than the yellow thing you have, or would you prefer something that's potentially not perfect with streaks? So really the decision is yours with that. But you can use like a foam or a mousse. It's no problem at all. So the big question everyone has is, how long will this last? Is it a permanent solution? Well, it depends on a lot of things. It depends on how much oxidization has occurred in the first place, how bright you managed to get this afterwards. But the key to take away from this is, don't have impossible expectations. Even with all the equipment, you know, the best UV source, the best strength of H2O2, it's going to work, but it's not going to be perfect. You know, turning ABS white plastic might yield more of a light gray result, for example. So it really depends on the plastic, the product, and the amount of oxidization it has. So in this example here with the Nintendo, it's actually lasted 3 years now. I filmed this video 3 years ago, and it still looks pretty good, to be honest. The Dreamcast, however, around 2 years, it started going a little yellow, but nothing like what it did at the start of the video. So is it a permanent solution? No, of course not. It's like when you get your teeth whitened. You don't get them whitened once and they're perfect for the rest of your life. It's just something that you need to keep doing. But after this process, where are you putting the item? Are you putting it back in the window where the sun can get at it? So it does depend on a lot of factors. But is this a permanent solution? No. But how long will it last? Quite a long time, and it depends how you care for your product. So I hope you liked the video and some of the experiments I did and all the information on UV and hydrogen peroxide. Let me know how your projects did, what you retrobrighted, what the results are like. Comment on the video below and let me know how it goes. I hope the information in this video was helpful. Take care, like and subscribe, and stay tuned for the next video.